So let's give you a rundown of part of what's going to happen today. I want to get this section finally finished. So I've broken it into like 5 main categories. There's a lot of different kinds of questions in these homeworks. I think that just adds to the problem, isn't it? You only get like 2 shots at a question, then the next question is something totally different. So these numbers in red are the homework questions that are like the ones I'm going to do. So I'm going to show you some APR calculations. I'm going to show you a very complicated version of how you can calculate how much your interest on your credit card is. And we're going to use this thing called the average daily balance, which is actually the more common version that credit cards use. So out of the 3 versions they could use, they would use that one. The one I would love them to use would be number B, because you'd pay less money on the same interest rate, but that's probably why they don't use that much. So we're going to do an average daily balance one. We're going to look at these questions here, where we're looking at add-on interest and what you can get, either a choice, 0% interest, or you get the car for less, but you pay interest. And we're going to look at how much you pay in both cases, see which one is the best deal. Payday loans, we've talked about it. I want to do some more of those guys. And the last one is about buying a car, but in particular, buying a car and calculating what's called the annual percentage rate, the APR. And sometimes called APY, but the annual percentage rate. That's very important, because it's a legal requirement that whenever you enter into a loan situation where you're borrowing money or buying something, they need to tell you what the APR is. And the reason they need to do that, it makes it easier to compare 2 or 3 different companies or choices. Because one of them might sound better to you just by the way that the numbers come at you. And I'll talk more about that when we get to it. So let's get started with the first one, questions 10 and 11. And these are APR questions. Oh, I already kind of prepared some. Here are some examples of very simple APRs. If you are told what the interest rate is monthly, daily, quarterly, whatever it is, then you can get the annual percentage rate, the APR. And it depends on this guy here. If you're being charged 0.5% per month, right? So it's a monthly charge. To get the APR, you go 0.05. Sorry about that, I'm slow. 0.5 times 12. It's already a percentage, I don't need to undo it. And this guy ends up being what, 6%? So if you are paying off something and the monthly rate is 0.5%, then the annual percentage rate is 6%. In other words, you're paying 6% a year. That kind of makes sense, right? 0.5% times 12 times, you got it. If it's a daily rate, it's 0.2%. And this has cropped up more than once, which is really annoying for everyone. I've seen 2 questions where it was 360 days they used instead of 365. And I can't think of why. I think at least in one of them, they did tell me it was 360 days, which was fine. But in another one of the homework questions, they didn't tell me it was 360 days. And it wasn't until someone sent me a question saying, I'm not getting this question to work, that I went and looked at it and found out it was 360. When you get a test, will you trust me that I'm not going to do that to you? 365 days in a year, guaranteed, no weird stuff, right? But this is, let's say this is a 365-day story. You just go 0.2% times 365, and the answer ends up being 73%. Can you imagine why it's kind of helpful to know that? See, if they say, oh, the interest rate's only 0.5% a month, you can afford that. Well, that ends up being 6% a year. That's actually not horrendous. Oh, come on, it's only 0.2% a day. Yeah, it is. Look at how much it adds up to in a year. Do you see why, if this was one company and this was the other company, wouldn't you be picking this one? Wouldn't you be taking a 6% rate? That one looks better because it's a small number, but if you actually look at it and it's the same thing you're buying and everything else is the same, then that is scarily bad. And the third one I've got is quarterly, just to show you can do that. So you could be 8%, 0.8%, sorry, and you're doing it quarterly, so it's 4. So the answer is 3.2%. Are we comfortable with those types of questions then? They're pretty easy to do. You just have to interpret what they're asking. Are we good with that?
Yes.
Right. So I'm just going to move on to our next topic. I'll do a little check mark. Done. We're going to do, this one is going to be a bit of a tax, right? This one is going to certainly, you have to think about it, and I'm going to be as slow as I possibly can, so I'm not jumping through it. But essentially, we're going to have a story involving a credit card, question 12. And in my version, you have $500 in your, that's how much you owe, right? Over the month. And you're going to pay off $300. The interest rate is 18%, which is not unusual. I've seen credit cards at 35%. So, that is not as weird. That's pretty good, actually, in the big scheme of things. Now, in this story, they tell you there's a thing called a 10-day payment or grace period. Essentially, you get 10 days in which that payment actually kicks in. Now, the reason they do it is that you might pay $300, but if you use your bank account to pay somebody else's credit card, it could take 10 days for that to for the money to leave one place to go to the other place. And they just, that's overkill. It probably only takes a day or two, but they're calling it 10 days. So this is a 10-day until they receive payments. And in this particular calculation, it's a month with 30 days in it. So there's the whole story. You had $500 in your credit card. You're going to pay back 300 of it. You've got an interest rate. There's this horrible 10-day waiting period. And this month that you're paying it off in is 30 days. So all of that information is going to be put together, and we are going to find the finance charge, which is the interest that you would pay using what's called the daily balance method. And that's actually a very common way in which credit cards do it. So I've just kind of went over the information. So the first thing you're going to do is get the previous balance. And what I mean by that is the $500. And then you get what's called the adjusted balance. Now, if you have 500, but you pay 300 off, then the adjusted balance is what you still owe. And so in this story, you're still going to have $200 on your credit card, right? You still owe that amount. You didn't pay it all off. So far, so good. None too sneaky yet. Now, this fella, the adjusted daily balance. These 10 days, according to the credit card, you still owe them $500. So you're going to have 10 days where you owe them 500, plus the rest of the month, which is 20 days, where you only owe them 200. And that is divided by the 30 days in the month. You want me to go through that again, where the numbers are coming from? Right. 10 days at 500, 10 times 500. The other 20 days in the month at 200, divided by the 30 days in the month. Now, I'm going to do that guy on the calculator. Do it over here so I don't need to jump around. Put a bracket in, do 10 times 500 added to 20 days where it's 200, close the brackets, and divided by the 30 days in the month. And the answer I get is totally wrong. No. It's just a very nice number. I was expecting an ugly number. Right, double check it. 10 times that. Cool. 20 times that. Divided by 30. Yeah. So the average daily balance is $300. Now, do you notice it's not the money that you owed at the beginning and it's not the money you owed at the end? It's kind of somewhere between the two. It's an average. Are you happy about this weird guy called the average daily balance? Okay. Now, finance charge is going to use this formula, PRT again. The interest, that's what your finance charge really is P, R, and T. P is going to be your average daily balance. R is going to be your interest rate as a decimal. Now, what is time going to be? In this story, time is, years or bits of years, agreed? Now, in credit cards, it's bits of years, right? So, what fraction of a year are we talking about in this story? 30 days? Out of a whole year. Isn't that the fraction of a year that 1 month would take up? Now, do you know it's 30 out of 365? Now, there is another possibility. Couldn't I call it 1 out of 12? 1 month out of 12. Do you know 1 out of 12 is not the same as that guy? There's a little bit of wiggle room. Right. So, knowing WebAssign, it will pick the different one than the one I picked. I'm picking that one. So let's find out how much interest you pay. $300 times 18% as a decimal times 1 month worth of years, which is 30 days out of 365. And the answer that we come up with is $4.44. Which isn't a lot. But then again, you didn't have a very big credit card, did you? The balance on your credit card was tiny. Do you want me to do another version of this question with some more numbers so you can go through the steps again? Okay, I got nods. I've got that. Okay. So I need a new story. So how much money is in this person's credit card? Give me a number. That's
about 350.
Oh, come on. They're in more debt than that. Give me a bigger number.
5,000.
1,700.
4,000. Okay, 4,000. That's bad enough. Okay, you've got $4,000 in your credit card. And you're going to make a payment towards it. Just to make the numbers nice, let's say that you decide to pay $1,000, right, off your credit card, right? You pay it towards it, try to reduce it. We're going to keep this one fixed because it seems to be a standard number that most credit card companies are using when they do this. So it's 10 days to receive the payment. Should we have a different month this time? Do you want to do it in February? Do you want to do it a 31 day? Should we do a different number of months, days? Yeah. Okay, let's do a 31 day month. Okay, we're going to have an interest rate. You have horrible credit, this person. Now, you might cringe at that, but you know there are some people who are paying that interest rate right now on their credit card. Right? It is not a good number by any stretch of the imagination, but it is quite realistic. It does happen to some of you. So I do my little wall so that this is stuff we know. We're now going to calculate the finance charge. So there's a guy called the previous balance. And in this case, it's $4,000. And then we have the next guy is called the adjusted balance. And it is the 4,000 that you owed, take away the 1,000 that you decided to pay it, pay it down with. And now you've got an adjusted balance of 3,000. And now we're going to calculate the average daily balance. Show how it works. 10 days at the big amount. 10 days at 4,000, because according to them, they haven't got their money yet. So they're charging you as if you never paid a penny. Added to that, the rest of the month. Now, since this question has 31 days in it, would you agree that the rest of the month has got 21 days? Right, 10 and 21. Times the adjusted balance. So 3,000 goes there. And the total number of days is still 31. Do you see how the 31 goes there? And that's called the adjusted daily or the average daily balance. Now I'm going to go here and try and put that into the calculator. Bracket 10 times 4,000 added to 21 times 3,000, all divided by 31. Now I can tell you right now what the answer is going to be. Not exactly, but I know roughly. Won't it be somewhere between 3,000 and 4,000? Right. If I hit this enter and it says it's 8,000 or 59,000 or something ridiculous, I'm going to know I screwed up. And the answer I got to the nearest cent is 3,300 and stuff. So that is the average daily balance. Now let's get the interest rate. The interest, the finance charge is what that is. The interest is PRT.
Okay.
It's the average daily balance, which is 33,200 and no, it isn't 33,000. 3,000. Let's do it here. 3,322.58. The interest rate is 0.35. And time is going to be 31 days out of a whole year. Or maybe 1/12 if WebAssigns deciding just to have 12 equal months. Right, here goes $3,322.58 times the interest rate as a decimal times 31 days out of a year. And the interest is $98.77. Now that is just the interest. That's just for borrowing $4,000. Normally what credit card companies do is that is not your bill. Do you know you get a credit card statement that says we want so much money this month, right? That thing. It won't be that number. It'll probably be a number like $150, that kind of number. Because what they are trying to do is that's what you owe them. And then they add a little extra so that theoretically, at least, you're reducing what you owe. If you look at your credit card statement, it will say something like this. If you only do the minimum payment, which is what that's called, it will take you 11 years to pay off the credit card debt. And when you're finished, you'll have paid $18,000 in interest. You ever seen that at the bottom of your statement and you wondered where it came from? Now, that's essentially what it's saying, is that based on this type of calculation, if you just did that and then you never used your credit card, right? You just left it and kept on paying the minimum until it disappeared. It takes you a huge amount of time to do it, and the total amount that you end up paying is horrendously big. So if you need to get into debt, right, it's not a good idea to use a credit card as a way of doing it. It's very convenient, isn't it? You got a piece of plastic, you buy your dinner, you buy your TV, whatever it is, and you don't really feel the damage. And then when you look at your statement, it doesn't look that scary. Oh, okay, 150 a month, but you're almost like paying it for the rest of your life. Well, a big quarter of it anyway. Right? If you really need to get money, go to the bank and hopefully you can get a loan. And that loan will probably be a 4-year, 5-year loan, and you can pay it off, and it might well be the same amount, but you will get a lot more than $4,000 worth out of it, right? You could probably get an $8,000 loan and pay it off over, say, 5 years at that amount. So it's a cheaper way of getting money if you need money. Are we comfortable now that you've seen the second one, how this thing works, or do you need a third one?
No, I need when I do them on the homework for them to work out as well as they do in class.
Okay, that I can't help you with. That'll happen.
I feel like I make some calculator error and it's hard to tell like what it was. So, but when I do them in class, they work perfect. I don't know about anybody else, but my calculator is like amazing in class. Not when I'm doing
it knows I'm here, so it's not going to do anything weird. But the minute I'm not here, it starts playing.
Exactly. The minute I have no one.
I hear you.
So I'm trying to work out one of my problems to make sure that it works, and I got the formula enough to replicate it.
So, any festival the holidays until Sunday, please? Until Sunday, yeah.
I don't think we want to hear that conversation. So if ever it is that is talking to someone, if you don't mind, I'm just going to mute you as soon as I get the right button. I have to go out. I have to go over here. I have to mute you. So you're going to have to hit the space bar now or unmute yourself later. And, you know, people don't want to hear your conversations, I'm sure. You don't want them to hear them at least. Right. Third topic, homework questions 14 and 15. I've got some purchasing, I think it's a car, but the key here is it's going to use the add-on interest method. So in these two questions, you're given a choice. And the choices are, we'll give you 0% interest, but the car's going to cost you $30,000 and you're going to pay it off over 3 years. Right, that's deal one. Or they'll give you a $5,000 rebate. In other words, you won't pay $30,000, you'll pay $25,000 for the car. But if you make that deal, they're going to charge you 3% add-on interest, as it's called, and it's going to be for the same 3-year period. Now, the question that we're going to eventually answer here is, which one of those two is the best deal for you? Is it cheaper to buy a dearer car with 0 interest on it, or a cheaper car where they add the interest later, right? It's add-on interest. And it's not always the first or the second one. Do you know, it depends on what the interest rate is and how big the rebate is. So one of them may be better in one situation and the other is better in the second situation. So wouldn't it be helpful if you could figure that out yourself, so that if you ever do go for a car, you say, okay, what's going on here? Oh, I like that one because I know I'm going to pay less money in the 3-year period. So let's start with the 0% interest, $30,000. We are going to find out what your monthly payment is. And this, thankfully, is not a hard calculation. You could probably figure it out yourself. If you're borrowing $30,000 and you're going to pay it over a 3-year period, monthly, aren't you going to do 30,000? 36, right? 36 payments. And let's see what that ends up being. So if you wanted to get that car, 30,000 divided by 36, oops, delete. I get $833.33.
Where does the 36 come from?
It comes from 12 monthly payments over a 3-year period. You'd have to look at that number and say, you know, how much do I make a month? And I've got to pay my rent and, you know, my credit card and my electric and all the other things in your life. Can I afford that? So I don't think there's a lot of us, well, maybe some of you, but definitely not me. I don't think I want to pay that kind of money. You agree that's probably too steep for me. So I wouldn't buy that car. I'd get what I normally get. I get a second-hand car, you know, $10,000 car, a lot less money to pay for it. Right. Well, that was an easy one for the first one. Let's look at the second method. Well, first we have to figure out how much the cost is, because if you do this one, they're going to get a rebate of 5,000. So I'm not going to, my car isn't going to cost me 30,000. Allegedly, it's not going to cost me that. It's going to cost me 25,000. Well, you might think, oh, well, take that deal. Well, don't be so quick. We might still take that deal, but don't we need to find out how much we're paying a month? Because that's really going to tell us which one's the best deal. Now, when you do an add-on interest, right, you're going to do well, there are two versions of this formula. The one I like is the future value one. So that's what I'm going to show you. It's P1 plus RT. Now, what that will tell you is the total amount that you will pay based on 25,000, because that's what P is, and an interest rate of 3% over a time period of 3 years. So based on that, it's 25,000, 1 plus 3% times T. Now remember, T is years. So in this case, it's 3. So do you notice it's not 36, but 3. 3 years times 3. Now, I'll do that calculation. 25,000 times, put a bracket around it, 1 plus 0.03 times 3, close the brackets, and I am going to be paying 27,250. But I still want to find a monthly payment, although I already kind of know what my choice is going to be. Do you agree I'm going to pick this one? Won't I buy the car using this method? Because won't I end up only paying 27,000 for it rather than 30? But let's do the monthly payments. 27,250 divided by, 36, right? Still 12 years, 12 payments, 3 years. So let's see what that cost me. 27,250 divided by 36, and I will be paying $756.95. So if you take the 30,000 but no interest, you're going to pay $833. If you take the rebate, which is 5,000, you'll get a cheaper car. The add-on interest rate still comes out better, doesn't it, in the end, than 30,000 did with the top one. And if you did this one, your monthly payments, right, there are 36 of them, you're only going to be paying $756.95. Are we good? You want to see another one of these? Okay.
Yes, please.
Let's do another one. New story. Well, it's still going to have two parts. You're still going to get zero interest, or you're going to get one of these add-on interests. So let's see if we can pick a cheaper car. So it's a second-hand car, so it's only 15,000, and that's what it will cost you. And you're going to get 0% interest rate, and you're going to pay it off over 5 years. Now, that's the kind of deal that you might get if you don't have a lot of money, right? You don't have a lot of spare cash, but you still like a car, right? You still need a car. You'll go into the, the car sales place and you'll, oh, I kind of like that one. I wonder what its payments are going to be. Well, since it's exactly what you see is what you get, your monthly payment is going to be 15,000 divided by, well, isn't it, monthly. We're assuming everything's monthly, right? So 5 times 12, what's that, 60? So 15,000 times, or divided, I should say, by 60. And 15, 1, 2, 3, divided by 60. And you're going to be paying 250 a month. Yeah. Would you think that's doable for a lot of you? I could probably, I could handle 250. I couldn't handle that, and I don't even want to even think about that either, right? So that's not for me. That car's just, it's not in my ballpark. But this car, yeah, not bad. But they gave us a choice. They said, well, you can do that, but we've got this special deal. And you think, oh, I like special deals. What's the special deal? We're going to give you a rebate, right? Manufacturer's rebate or company rebate, whatever they want to call it. And this rebate is going to be $2,000. So guess what? You only buy this car for $13,000. Right? I've done the calculation, right? And you're thinking, ooh, that sounds like a deal. So what's the catch? Well, they won't call it a catch, but you're going to pay 10% interest over 5 years. Right? So it's the same period of time. Now, do you see that guy? Not a good number, is it? This might not be a good deal anymore, right? Let's find out what it will be. The amount that you would pay, right, is P 1 plus RT. 13,000, that's good. 1 plus an interest rate of 10% over a 5-year period. You will end up paying 13,000 times a bracket 1 plus 0.10 over a 5-year period. You will end up paying 19,500. And just so that we compare like with like, let's see what that is as a monthly payment. $19,500 divided by 60. And that ends up being 325. I think it's a no-brainer that in this story, don't you pick the 15,000 zero interest? Right? It's the same car, right? All you're doing is looking at different financing deals. That kind of, I deliberately picked a big number so that would harm. Isn't that kind of a warning sign if the interest rate is really high, that it's probably not a good deal? I mean, you'd have to look into what the rebate is, because that could affect it. I mean, if they went silly on you, suppose they said, oh, we'll give you a $10,000 rebate. Never heard of that, but if they did, couldn't this end up being cheaper again? Yeah. So it's a combination of what the rebate is and what the interest is. That will decide whether the untouched version or the add-on interest version is going to be a better deal. Now, these are very real. This is very realistic. I've seen adverts. I'm not interested in getting a car right now. But have you not seen adverts on the TV where 0% interest or something? You seen those ones? Right. You could go to that place and see if they do any of this. Because it could be, couldn't you, if you get a good rebate or a very small interest rate along with a good rebate, couldn't you end up paying less than a 0% interest? Could happen. So it's worth looking into. And if they tell you, oh, we can't do that, find another place. Just leave and go. Because the answer is they can do it. You know, a car sales place can decide any finance situation they want. Do you know, if they wanted to, couldn't they sell the car for half price and just go bankrupt? I mean, if they wanted to. So there's no law that says, oh, we can't do finance deals, or we can't do rebates, or we can't do anything. They choose not to, that's fine. But probably the reason they're choosing not to do it is, don't they want to get the most money out of you? So they're not going to give you a choice where one of them's cheaper than the other. Are we good? Before I leave this, just because I want to, do you know when you buy a car, you don't own it? Do you know the finance company, whoever the loan is to, bank probably, but it might be other things. Do you know they own the car until you pay the last payment? And then it's yours. And what happens if you lose your job and start paying and can't pay? What do they do? Right? Don't they repossess your car because it's theirs? And don't they sell that car somewhere? And if the money that you owe is more than what they got when they sold it, do you know you're still on the hook for the last 2,000 as well? Do you see that it's a win-win situation for them?
Even better if they sell it and they make money off of it, you don't actually get that money.
Oh no, you don't.
Like I had that
you don't.
They got a bill and that said that they repossessed the car. They got a thing and it said that basically, lucky for you, we were able to auction the car. The car auctioned for like 7,000, but they only owed like $2,000 left on the car.
Oh.
And
that is painful.
All of a sudden she's like, well, where's my money then? If you sold my car for more than I owed. And they were like, yeah, no, that's not how it works.
It doesn't work that way. Yeah.
They're covering their fees and they're like, yeah, because we repossessed it, it's no longer yours, even though she'd already, but it was the same thing. She lost her job and her husband passed away. It was a horrible situation for her.
Oh God. Oh,
it was like,
she
was like, oh, $5,000. That means like they have a check for me, right? No.
Well, I mean, it's over and she couldn't have done it. And I can understand in her situation, she wouldn't have time or even thought of this. But if you have a car, you can go to a place and get what's called the Blue Book value. So you can find out what your car's basically worth. And if you know you owe 2,000, right, but the car's worth 7, you could easily, I hope, find somebody in your family that says, okay, look, just give me the 2,000, I'll pay off the car, I'll sell the car and I'll give you your 2,000, or maybe I'll give you 3,000 for being so nice to me. And, you know, she would have walked away with some money. So look into, if you ever get to a place where you're in that, you know, I know I'm not going to keep up with my payments, you might want to look into the value of the vehicle to see whether or not that's a worthwhile deal, you know. Yeah, it's a sad story, but same thing happens with your house, of course. If you don't pay up in your house, don't they repossess it? Eventually.
Yeah, I've heard that's why people put concrete in their pipes.
Yeah, well, I'm not condoning that either, but yeah, I can understand why people would not be happy. Okay, we've done those. I'm trying to figure out where the heck I am. You all know where I am now, aren't we? On question 4 or topic 4. which is question 16 and 17. So we are going to look at payday loans now. We have looked at these before, but I think it's worth just returning to them. I'm going to go to question 16 on the homework. You can bear with me for a few minutes. Okay. Here is a very typical way that payday loans work. You go into a payday loan place, and for some reason, I don't know, maybe it's your electricity bill, and you don't want to lose your electricity, so you're desperate. And trust me, you better be desperate before you use this place. They charge you something like, it's not uncommon, $1 per $100 you borrow. Per day. So if you want to find out how much it would cost me, the going rate is very common. $1 for every 100 you borrow per day. So let's suppose we have a story. I'll change color. And you need $500. And you're going to be able to pay it back in 7 days. Right, when you get next week's wages, right? So you know it's going to cost you 7 days to do it. Let's find out how much interest, which is what they call the finance charge, right? Well, $500, would you agree that you take $500, if you divide it by 100, I'm doing this as a calculation, but wouldn't that just be $5, right? But it's per day. So you would end up having to pay back another extra $35 on a $500 loan. You agree? That's pretty obvious how you do it, right? Now what we're going to calculate is the scary one, the interest rate. Now, we have a formula. The interest is P, R, and T, agreed? Now the interest, not the interest rate, but the interest is $35. P is the money that you borrowed, which was 500, times R, the thing we're really looking for, right? We're interested in R, the interest rate, times time. Now, isn't T a year or parts of a year? So this is where it gets a little messy. 7 days out of 365 days. You with me so far? Now, what I typically do in a question that looks like this one is that I find out what that guy times that guy is. So I'm just going to go to my calculator and I'm going to find out, okay, if you take 500 and you multiply it by 7 and then you divide it by 365, you get this ridiculous looking decimal. And they're always going to be ridiculous looking decimals. In this case, 9.589. So far, so good. Now, what do I do to both sides to get R? $35 is this guy times R. What do I do to both sides to find R?
You're going to divide.
Yeah. So I'm going to take 35 and divide it by that ridiculously ugly decimal. And so here goes. 35 divided by 9.589. And the answer I get is 3.65. And you're going to think, oh, that's all right. 3.65%. Sorry. That's the interest rate as a decimal. $365% interest rate. 365. It's just interesting that it's the same number as how many days in the year. 365. I can't think of a worse way to get money. Couldn't you do a cash advance loan on a credit card and it wouldn't be as bad as that? You could go to the bank and say, can I have an overdraft? And it definitely wouldn't be as bad as that. So the thing that still amazes me to this day is why these places are even in existence. Who in their right mind would use a payday loan? Is it just desperate people who don't have a bank account, don't have a credit card, and just need that money? I mean, because I can't think of anybody else who would use it.
Part of that, it would be that, and the other part of it would be shielding from political shielding from people, you know, because these people, they can make so much money, they buy their politicians.
Oh, buying politicians is a favorite pastime. You know, it's not illegal to charge 365%. It's just, it's like robbery without violence, I guess. I don't know what it is. But I'm thinking from, why would you as a person go to a payday loan? I mean, can anybody give me a good reason why, a situation where someone would need to do it that way instead of the alternates that I've gave?
You see that a lot with desperate women. I'm a foster parent, and I've seen quite a few of the parents that I mentored end up falling for predatory actions like this because they've cut off all the other support loads. So
they don't have a bank account, so they can't get an overdraft, for instance.
Oh yeah, I mean, a lot of them have such bad standings with the bank. They've already maxed out their credit cards. Most people who in that, you know, that have children in the system are children that were already in the system. They don't have any family. It's an unfortunate thing. I do feel like our politicians should be protecting these people, not allowing it to be something that they can do to these vulnerable parts of our community.
It's almost like things are turned on its head. Do you know the richest people get the smallest interest rates when they borrow money? And the poorest people get the highest interest rates. There's something back to front about that, but that's just, I guess that, yeah, desperate people have to do what I have to do. It's just unfortunate. Do I need to do another one of these, or you're pretty comfortable about how to calculate payday loans? Do you want to see another one? Or are we good? I see a nod, but is that nod? You want another one? Okay, yeah. We got another one. Okay.
Just that, then I can write down the steps to it, and like it just helps a little bit.
Okay, nothing wrong with that. So we're going to have to get a loan, right? I don't know. $1,200, right? You got to pay next month's mortgage and you've got nothing, right? You're desperate. You got to pay it somehow. You don't want to lose your house. So you get $1,200.
No CC 5-minute warning.
Right. And you're going to pay it back in 30 days. Right. So whatever happened, right, you get paid monthly, which isn't a good idea, but a lot of people, I do, for instance, get paid 2 weekly, but some people get paid monthly. So it's going to take you 30 days to get the money back to pay it. Let's see what this poor soul is going to have to do. We'll keep the same rules about how much money it's going to cost. Well, if you take that and you divide it by 100, doesn't that mean that you're going to pay $12 per day? Are you happy about how I got that? You take the number that you borrowed, divide it by 100, and for each one of them you pay $1. So in this case, there's 12 of them, so you're paying $12 per day. Now that becomes 30 days, right? It's a long payday loan. And I'm deliberately making this one really ugly just to scare you out a little bit as well. This one is now $360. So you only borrow 1,200, but you have to pay an extra 360 at the end of the month, right? The next month. Okay, let's see what the finance charge is this time. The interest is $360. You borrowed $1,200. We're going to calculate the rate, and the time is now 30 days out of 365. Are you happy about I goes here, P goes here, leave R, T goes there? You're comfortable about where they come from, right? So the next bit is to multiply these two guys together to get an ugly decimal. So I go over to my calculator and I go 1,200 times 30 divided by 365. And the guy that I've got here, I don't put a dollar sign in yet, 98.63 R. So R is going to be 360 over 98.63. So 360 on the top divided by the 98.63, and the answer I got, oh, actually, 365%. Oh God, it's still horrible, isn't it? Do you really, do you really want to do that? I guess no. So the only people that do it are the ones that don't have any choice. Are we good with that one? I'll move it in a moment. I think we need a joke right now before we do the next one, because that's kind of sad and I want to cheer myself up. Did I tell you the joke about the couple that wanted a baby and got ahead? Do you want to hear the joke about the baby, the couple who wanted a baby but only got ahead? I at least need one student to nod their head, otherwise I could be inflicting. Okay, we got a nod, we're doing it. This Scottish couple wanted a child and they tried and tried, and eventually they got lucky, they had a baby, but when the baby was born, it was only a head. So it's a kind of sad story. And by the way, remember, this is a Scottish joke, right? But it was an intelligent baby. It could eat and talk and do everything, that a head could do. And it got to 18. In Scotland, when you get to 18, you're allowed to go to the pubs and get beer and whiskey, whatever you want. That's the drinking age in Scotland. So when he got to 18, the guy turns around to his son and says, "Son, I think we'll take you to the pub today. About time you had a beer." So he grabs his son and he goes to the bar and walks into the bar and he goes over to the table and he puts his son down. And he says, "My son's turned 18, give him a pint of beer." And the barman looks at him and says, "It's a head." He says, "I know it's a head, he's intelligent. Just fill up a pint of beer, stick a straw in his mouth and he can drink. He knows how to drink." And so he says, "Oh, okay then." So the barman pours a pint and he puts a straw and he puts it in his mouth and he drinks it. And something remarkable happens. When the head drunk the pint, his torso grew. Right, his whole torso, it grew back. And so he says to the barman, "Give me another pint." And he gets another pint and his arms grow back. He says, "Give me another pint." And the rest of his body, it grows back. So he turns around to his dad and said, "Look, it's a miracle. My whole body has grown back." He says, "I'm going to go away home now and get some clothes and I'll be back in 5 minutes. So he walks out the pub and he crosses the road and a bus knocks him down and kills him stone dead. It's a really sad story. Do you know what the moral of that story is? You should always quit when you're ahead. Oh, I wish I could keep these photographs and show you. Oh, well, I guess you can see each other. Some of you looked like you were taking a hemorrhage. I mean, your head was just, you were holding on to it like, oh God, no. That was a bad joke. Yes. Do you want to hear another one before we move on? Because I think we need to. I think you need a joke to recover from the other joke. Okay. Oh, you're saying for sure. Okay, then. Let's look at this. I'll do a Scottish joke because I like Scottish jokes. This Scottish guy goes into a bar in America at 12 o'clock, right, at noon every day. Goes over to the bar. He's on his own. He buys 3 pints of beer, takes them, goes to a little table in the corner. He drinks the first pint, he drinks the second pint, he drinks the third pint, and he leaves. Every single day, same routine. 12 o'clock, 3 pints, drinks, leaves. And after a few weeks, the barman can't control his nosiness, his inquisitiveness. So when the guy comes in at noon, he says, look, I notice you do the same thing every time. Why do you buy 3 pints of beer and it's always noon and you drink them on your own and then you leave? And, why? And the guy says, well, it's a tradition. He says, when me and my 2 brothers, when we all lived in Scotland, at noon we used to meet up and have a pint. And we kind of decided that now that we've moved to different parts of the world, that no matter where in the world we are, at noon, we'll always go into a pub and buy 3 pints of beer and we'll drink them and it'll keep the tradition going. And the barman thought and said, oh, that kind of makes sense. Yeah, okay. And he's happy. And the next day, the Scots guy comes in and he goes over and he says, 2 pints of beer. And he takes them and he goes to the table. And the barman's thinking, oh God, something terrible's happened. There's only 2 pints of beer. I've got to find out. So he goes over to the guy and says, look, I don't want to be too nosy, but I did notice you bought 2 pints of beer. Is there something wrong in the family? And the Scots guy turns around and says, no, he says, there's not a problem. I've just decided to give up drinking.
That's cute.
No? God, you're a tough crowd. Okay. Well, now that I've done that, are you more ready for the next question? Because that means I've stopped telling jokes. Right, I'm assuming. Okay, if I get something in the chat that I should know about. Oh, ouch. Okay. Let's return to where we were last time now. We are going to look at, yet again, buying a car. But I mean, you could say almost anything, but this question is about buying a car. And let's give you the story this time. This is me doing a version of question 18. So for a car loan, give the following information, right? So this car is being advertised for $9,000, okay? And nothing down, that's good. And 36 easy payments. Of $302.50. So this car is $9,000, but if you want to get it from me, it's a car salesperson, 36 easy payments. They never say 36 hard payments. You notice that? They always say easy payments, no matter how big they are. So 36 easy payments are about $302, and we're going to be asked to do a number of things. So here is the first question. What's the amount that you actually paid? Now, it's actually not $9,000. If you gave them $9,000, you could drive away with the car and it's yours, right? You're going to have to do this, fella. Well, I think it's not too difficult. Would you agree? You just multiply 36 payments of $302.50. So put this one in the list. Oops, clear. 36 payments times $302.50, and it ends up that you pay a little bit more. That doesn't seem unreasonable. Would you agree that, you know, if you pay cash, you get a better deal than if you pay it off over 3 years? It's not extortionately big, so I think that's fair. I don't think that's it's not a rip-off. And that's, if you like, the first thing you're going to be asked. Now, I guess they called it A. So question B then says the amount of interest that you pay. So 10,890. It would have been $9,000 if it was cash. So that guy. Do you know they could have also called that what was the finance charge, and it would have been the same calculation and the same number, right? Because interest and finance charge are essentially equivalent, aren't they? Depends on what words they want to use. Well, you kind of could do that in your head, right? $1,890, that's how much extra you pay. That's called the interest. C. The interest rate. Well, that guy divided by that guy times 100. So the interest was $1,890. We're going to divide it by 9,000, and then I'm going to times it by 100, and I get 21%. But divided over 3 years, so it's 7%. You're only paying 7% each of the 3 years. If you don't like the way I did that calculation, let me show you another way of coming up with it. Isn't interest P, R, and T? Right. Let me do that same calculation and come up with 7% for you. So the interest is 18,000. No, it isn't. It's 1,890. That guy is 9,000. That guy is that, and that guy is 3 years, right? So it's 18,900. Right? That guy times that guy is 27,000. If you then take this number and divide it by 27,000, you get the interest rate as a decimal, which then becomes 7%. Are you happier if I do it that way? Does it make more sense that the interest rate is 7%? And you would expect that to be the finish. But they have one last thing, which is why this is a little bit different. This is the interest rate per year, right? Basically. But we want to find what's called the APR. And the reason why that's different is if you are paying off $9,000, at the end of the first year, don't you owe less money? But you're still paying off the same amount of money. So the interest rate is really changing each year. And that's not a very fair way of calculating how much you're really paying. Right? Because 7% a year doesn't look bad, but if you do it over 3 years, isn't it like 21%? It feels wrong. So how do you calculate APR? It's this fella. No, you can't say it. It's this fella. Oh, you can. Down here. N, in this case, is going to be 36. N is the number of payments. So 3 years, 12 payments, 36 payments. So it's going to be 2 times 36 times the interest rate. Now, if we keep the interest rate as 7%, we can do that. And N plus 1. So I just need to go bracket. 2 times 36 times 7% divided by bracket 36 add 1. And that's just the magic formula that they give you. And that ends up being 13.6%. Now, there is a different version of that question. You can go 2 times 36 times an interest rate as a decimal. If you do that calculation, you will get 0.136, which you then have to convert into percent. So do you see that they both give you the same answer? If you're just comfortable that you should always use decimals, you might want to use this version of the formula. Since I know that this is going to do it slightly quicker, that's why I chose it. So actually, the overall interest rate on buying this car is 13.6%, which is a bit higher than maybe you thought it is. But if you go to a car salesperson and they try and sell you a car, they're legally obliged, and if they don't, there's something shifty going on, to tell you the APR. So you can say, well, what's the APR? And they'll say, give me a minute, 13.6% over the term of the loan, right? And then, I don't like that. So you go to another car place and maybe they'll give you 12%, right? If everything else is the same, don't you pick 12% over 13? It makes sense that you always try and pick the cheapest if everything else is the same. Do you want to see another one of these guys? Or do you feel this one's a little bit more obvious?
I have a question that might be obvious.
I'll go for it. I like obvious because it probably means it's a harder question than you think it is.
Oh, well, it's
I give daft answers to good questions, so go for it.
Oh, I guess my question is, when we're taking the exam at the end, do we need to have all of these formulas memorized, or will they be available?
You won't. I won't give you them either. What
Okay.
you do is you write down on a piece of paper every formula that you know you've used, and you might also want to write down on that piece of paper the situations that it would get used in.
Okay.
So do you know that horrible formula that we did where we talked about the credit card? Right. You know, the one where you had to do the average daily balance calculation?
Yeah.
If I was you, I would make up a pretend version of that question with nice round numbers just to make, you know, it easier to read. So not only do you have the formula, you also have with it the process that you would use to do it, right? So that's the way I would tackle those questions. So, you know, look at all the kinds of questions that you've seen, and there's a lot of them, right? And you say, okay, if I see a question and it talks about APRs and cars, then I'm going to have to remember this formula, but I probably should write down all the other stuff and how I got it. And so if you can write small, it's helpful, but if not, have it in a big piece of paper and have it at the top, buying a car, right, with APR in it, right, or something, so that you can say, which one am I using? That one. And then it's a guide to it.
Thank you.
Right. Is that helpful? See, the reason, I mean, I could certainly easily give you a formula sheet, but the problem is the only thing I would give you would be the formula and not the context. So you would just have 20 formulas to look at, but no idea which one was the right one. So I think it's much better idea if you write your own, because when you write things down, won't it make more sense to you the way you write it? And so you'll be able to figure out which formula for which story, because you'll recognize the story in maybe a slightly different way than someone else would. But it only needs to make sense to you, right? It doesn't need to make sense to any other person in the universe, just you. We are doing good. We are finished with this section. And I need a few moments. And no, I won't tell you a joke because you were so bad with the last joke that I feel hurt now, and I don't want to do any more of them because you're making me feel sad. You know none of that's true, don't you? Okay. The next guy that we're going to deal with is homework chapter 11.5 annuities. I think it's 11.5. So let me tell you a little bit about what's going to happen here. Annuities are not in this block of homework. Homework is WebAssign 11.1 Part A, 11.1 Part B, and what we just finished installment, right? That's what's due this Sunday. What I'm about to do right now won't be due until another 2 weeks. But if you have time, you might want to start it and do some of the questions. Just because wouldn't that mean less homework the next time, right? If for no other reason than that. So we are going to look at annuities, and I'm going to jump right in at the deep end and scare you. And then hopefully show you why it's not as scary as it might seem. Let's talk about the good news. You don't need to know what formula to use because it's in front of you. The bad news is, would you look at how ugly that formula is? That's the scary part. What I'm going to try and do is show you how to do that calculation, because there's a lot happening in it, right? How to do that calculation using your calculator. And what I tend to do with these types of questions is I break them down into smaller, manageable chunks. Because if you try to hit all of that into your calculator at the same time, can you trust me, you'd have so many brackets inside brackets that you'd lose place. And Tara would be screaming at me because none of her questions end up working. And she thinks she's hitting all the right buttons, but she doesn't know which ones, right? So we want to avoid that type of situation. So I'm just going to write that formula down, and then I'm going to return back to the screen, the whiteboard thing that I use, and show you how to do this question. In manageable chunks. So let me tell you what this weird thing calculates, because that might be interesting to quite a few of you. Essentially is what's going to happen here is that you're going to pay into, well, different companies. Banks will do this for you, but financial companies, you know, like Peril Insurance will do this for you. Investment companies, all sorts of different companies are geared towards these things called annuities. Essentially, it's a saving mechanism. And what you can do here is you enter into a contract with the company, and you pay in this number here per month. So M is the amount you pay per month. So you might form a contract with a finance company and you say, I promise to pay you $200 per month, and I'm going to do it for the next 10 years. So that would be called a 10-year annuity, right? Annuities very often get their name by how long they're going to last. For instance, if you wanted to do a retirement annuity, you might do a 30-year annuity. In other words, you keep doing this for 30 years. And then at the end of that 30 years, you will get A. That is the amount it's worth at the end. Now, compound interest is being used here, but that's fine. They're all compound interest. R is going to be the interest rate in decimals. N, in this case, in almost all cases, it's, now, let me redo that. Number of payments in a year.
So on the formula that says the annuities for the, what was it? For the, in the notes, it has it done as R. Is M, little m and big R interchangeable then? I just want to make sure. On
I
this,
don't know.
on this part of the notes, can you see?
Whose notes are they? Their
Yours?
notes? Mine. Oh, sorry.
They're yours.
I can't read that distance.
Yeah, it just shows it as A equals R, and then everything else is the same that you wrote. That's the only thing. It just shows that R. And then it says R equals, and then it has monthly in a parentheses. So I just want to make sure I didn't get confused.
No.
Because I like
yeah. Sometimes you'll see in my notes that R over N is called I as well.
Okay.
I think for ease of usage, because there's different flavors of the same formula, that I'm going to use this one because this is clearly the one that WebAssign's going to use. So when you do your
Okay,
homework
no, that's
questions,
fine. I just wanted to make sure when I was interchanging them and writing things down that I don't do it wrong.
No, it sounds like they're fine. So N is the number of payments. It's typically going to be monthly. I guess you could do it quarterly, maybe occasionally. That would be 4 then. If you did it yearly, wouldn't it just be 1? Right, N would be 1 in that case. What else is missing from this? I think we've only got one last thing. T is the number of years that it's going to work for. This is a very efficient way to save up for retirement. You will be given, depends on, the company that you go to, you'll be given different interest rates. So obviously you might want to shop around and see who gives you the best. And these interest rates can be variable or they can be fixed. Variable means that every year they change that number. It depends on inflation rate and all sorts of other things. They're not as good. I would suggest if you're going to do something like this, that you try and find a fixed interest rate and try and find the biggest fixed interest rate because that's going to get you the most money. But that's just me. I mean, you choose what you want to do if you want to do it at all. But here is our story. So let's have somebody getting ready to save up for retirement. So they're 35 years old and they're in a good career position, right? They're making a decent amount of money now, right? They've taken care of the family issues, so they know they're not going to have to do any more with that. They've got the kids that they're going to get. And so they're getting ready for, well, I need to think ahead here, and they're going to do a 30-year annuity, right? And he's gone to a financial company and he's decided that he or she is comfortable with $400 per month, right? It's like a car payment, isn't it? Instead of, paying for a car, right? I'm paying for my retirement, right? So he's got enough spare cash. She's got enough spare cash to do that. We're going to look at the interest rate. Now that fluctuates. Do you know right now it's probably not a good idea to get an annuity because they won't give you very good interest rates, because the interest rate right now is ridiculously low. But let's pretend that he managed to get a 4%. Right? be pushing it, but let's say you got one. Okay, so what is missing? Well, I got M, I've got R. Oh, I've already told you it here, but shouldn't I tell you it's 12 payments, N is 12? Right. So here's the question. How much money do you think that annuity is going to be worth? What's A going to be worth in 30 years from now? $100,000? 50,000? $1 million? Hard to tell, isn't it? Because there's so many moving parts. Because aren't you keeping on adding 400 every month, right? So that keeps changing. But don't you get an interest rate on the money that you've got, including the money you're about to add? So that's going to make the money grow. And then time is going by. So every year it's going to grow, right? So there are a lot of moving parts here, which is probably why this calculation is so darn ugly, right? It just needs a lot of different things to make it. So I'm going to start by writing down the formula. Then I'm going to put in all the numbers, 400, 1 plus 0.04 divided by 12. 12 times 30 years goes up here. Take away 1. Divided by 0.04 over 12. Unless you are really, really good at working a calculator, you are asking for a whole load of trouble if you try and do that in one go. Would you agree? It's just too much going on. So this is what I would do. Step 1. Calculate that ugly guy. Okay. Step 2. Calculate that guy. Step 3. Put the whole package together and get your answer. Now, you can't see anything there because I haven't done earlier calculations. So I'm now going to move over to the big calculator because I want to be able to show you, hopefully on a larger screen, all those calculations. So you're just going to have to trust me because I'm reading them off the piece of paper. But you're going to see in a few minutes what that looks like. So the first calculation was that 1 plus filler. So a bracket, 1 plus 0.04 divided by 12, close the brackets.
Are we supposed to see the calculator right now?
Yes, can you not?
No.
Uh-oh. Try it again. Can you see it now? Any calculator?
Yes, it's there.
Okay, so there's the beginning of that calculation. Do you see the 1 plus 1.04 divided by 12? Close the brackets, raise it to the power, and then it was 12 times 30. Close that little bracket, right? And then subtract 1. Right. Do you see that ugly number?
Oh, I just.
Right, do you see that ugly number? That's step 1 done. Okay. Now, I'm going to divide it by step 2. So I just hit divide and the calculator will use that. And step 2 was, put a bracket around it, 0.04 divided by 12. Close brackets. Good grief. Can I pause this? Oh, darn it in space. Did anybody see my mistake? I think it happened when someone said to me,
Yeah, right there.
I've done 1.04, haven't I? Oh, shooting space. Right. Pretend I never did that. I'm going to start with step one again. Brackets 1 plus 0.04 divided by 12. I had 1.04. That makes a big difference, by the way. Raised to the power of, put a little bracket, 12 times 30. Close the bracket. And then subtract 1. Okay, there we go. So that I should have noticed right away at the beginning. So that's roughly 2.313498, and I'm going to stop there because 6 decimal places is fine. So if I can just return back, that's the guy I did in the calculator. That's its answer, right? So we got one of them. The next guy is going to be this one here. This one is so small, I think I can just do it on this calculator.
Just hit my butt.
Are we good?
I'm sorry, I didn't know I was unmuted. My teenager just hit me with something. I was like, what is going on underneath me, behind me?
Your kid's beating you up. Okay.
Yeah, all their electronic plugs are behind me underneath the computer, so I can track who has what, because it makes it easier when I'm in school on Zoom.
Okay, I gotcha.
Someone was sneaking and they were not sneaky.
Uh-oh. So 0.00, right? So you got this guy, 0.00, 1, 2, 3, 4. So I'm doing everything to 6 decimal places. Now, this number is all of that. This number is that guy. So how do you get this fella? You take 400 times this guy divided by this guy. Now, do you see what I've essentially done is broken it into, I hope, manageable chunks. This guy and this guy. So it's 400, gotcha, times this fella, which is 2.3 stuff, divided by this guy, which is this thing. And now I can, well, I don't know. Can I do that in the little one? Because it's pretty easy to do. So 400 multiplied by 2.313498 divided by 0.003333. And the answer that we got is 277,647 and roughly 53 cents. So putting away, bring this back, putting away $400 per month for a 30-year period and getting an interest rate of 4%, you will have, when the annuity matures, when it finishes, $277,000. Would you agree that's a pretty good chunk of change to retire on? It's not a fantastic amount of money, but hopefully you've got Social Security, maybe you have a house by then, right?
It worked.
Oh, we got it worked. Yay.
Worked.
But if you think about it, isn't that a ridiculously difficult question if you try to do it in one go? So I hope my idea of breaking into pieces like this might help you, right? I think we should do another one. Actually, I think we should probably do 3 of these really to get a grip of it. So I need a new story. How long do you want this annuity to last? We did a 30-year, so pick something else. How long do you want?
Let's do 35.
Ooh. So you think you might get another 5 years working life. So you get 35 years to do this stuff, okay? I'm going to pick $100. Oops, sorry. We'll be back. Sorry about the interruption. Nobody should phone me unless it's really important. So I thought it was somebody thing really important, but it evidently wasn't that. Of course, when I start talking, aren't they going to ring back again?
Pretty much.
Guaranteed? Okay, so at least you're warning. Right, $100. Right. I'm assuming $100 is an extra, you know, it's not a lot. It's $25 a week, right? Doable for most people eventually. You know, once you've got your career established, I think it is. Let's do an interest rate of 10%. And that's a big interest rate. But can I tell you that that's the average increase in stock exchange? Now, over the life of the stocks, they've gone up 20% in a year and they've gone down 15% in a year, right? So it's a risk. But on average, stocks tend to go up about 10% a year. So you can get some companies that, especially if it's a 35-year time period, will give you an interest rate of that because they know in the long term, the good years are going to compensate the bad years, right? Unless they go bust. So 35 years, $100, 10% interest rate, that's good. We'll do this, we'll do this monthly again because I like monthly. I think we're ready, aren't we? So let's find out what this one is worth. Do you think that 10% is going to make a massive difference to the final result compared to a 4%er? Even although I'm putting less money in. Let's see. It's going to be $100. 1 plus 10% divided by 12 raised to the power of 12 times 35. Take away 1. All over that guy. So I'm going to have my step 1, my step 2, and then my step 3, right? So my step 1 is getting that guy. And I don't know why I called that R over N. Right, should have called it that, right? So I'm going to get that guy. Will I do it on this calculator this time? Save me jumping back and forward so you can kind of see the numbers as I type them. So bracket 1 plus 10% divided by 12, close the bracket, raise it to the power of, put a bracket around it, 12 times 35, close the brackets, okay, subtract 1, and the answer, 31.638650. So this guy in here, this bit here, is 31.638650. Okay. The second guy, a lot less work, 0.10 divided by 12. And this one here is 0.008333. So that's what that guy is worth.
No bracket.
Are we good with that one? Right, put the whole package together then. The annuity is going to be 100, that guy, times this ugly guy, divided by this ugly guy. Here goes 100 times 31.638650 650 divided by 0.008333. And the answer we got this time is 379,678 and 99 cents, which is actually more money than the other one. But in this one, it was less years, so that accounts for some of it, agreed. But it was more money each month, a lot more money each month. So you would think that would help this be bigger, which it did, but evidently not enough. What else was it? Oh, the interest rate was a lot lower, wasn't it? 4% against 10. So do you see how those three things together are always playing with each other? If you make one big, but you make the other smaller, couldn't you end up with less money at the end rather than more? Or more money at the end, you know, depending on the combinations. So I'm going to give you one to do. That's always the best way to test it, right? If I give you one and you can do it, then we know things are fine. So this one is a very short annuity. It's a 10-year one. Maybe you're doing it to get your kid to college, right? So you're going to save up for the next 10 years, right? And at the end of it, you've got some money that you can help your child go to college with, right? So it's a 10-year annuity. You've decided, it might not pay for all the college, but you've decided that you can put away $50 a month. The interest rate, let's say you manage to get a 6%, and we'll stick to doing it monthly. Okay, there's your question. How much money is that 10-year annuity going to be worth based on these figures? And I'll write down the calculation for you while you're hitting buttons. So it's going to be 50 times 1 plus 0.06, 12 times 10 times 12, take away 1, all over 0.06 over 12. You got 3 minutes, no pressure. I just had to look. It wasn't an important phone call. It's one of those 1877 things. So it's somebody trying to sell me something. I don't know how they get my number. I don't tell anybody. Okay, we're coming to the end. Here goes. This ugly guy first, right? This one's first. Go in bracket. 1 plus 0.06 divided by 12. Close the brackets. Raise it to the power. I like to put an extra bracket in for safety. And 10 years times 12. And then subtract 1. And the number I got here to 6 decimal places is 819397 if you round it off. Right, this fella now, 0.06 divided by 12, which should be a really nice answer, which it is. Great. And then final answer. 50 times that guy. All divided by this guy. No. 50 times 0.819397 and divided by 0.005, I get $8,193.97. Does that look right? To which I would say that ain't going to get you anywhere near college, right? What would 8,000 get you? A quarter, maybe? Just 1 quarter, okay. So I'm paying for the first quarter, maybe 2, right? I'm paying for the first 2, the rest is yours, right? So at least I'm doing something. It's easy to up that number, isn't it? Do you know if I doubled this number to 100, right? Right, if this became $100 instead of 50, it would double the amount that you would get here, right? So if you made that $500, this would become 100, whatever, 10 times bigger. It would be 81,000. That certainly would be enough for college. I think we've came to a natural stopping point today. This is a good place for us to finish. The rest of these questions, we haven't got to them yet, but the rest of the annuity questions are going to be things like, well, how much money a month do I need to put away so that I'll have $500,000 at the end of a certain period of time? You imagine the kind of questions where I tell you the amount and you tell me how much to save, rather than I'll tell you, this is what you save, I'll tell you the amount, right? So you switch places, and that's a common question. Well, we'll worry about that next time. So does everybody know what is due this Sunday?
Yes.
Right. And everybody by now should have logged on to WebAssign and should have had, if nothing, at least the 2 weeks grace period. Are some of you getting to the end where they're sending you the email saying you have to pay now?
I'm still okay, but I have my code just in case already, so.
Right. So remember, in case there's a weird transition, remember to phone them if it doesn't work easily. And they'll talk you through the process, because that's happened occasionally to some of my students. So, they're very helpful people. They don't want to make your life a difficulty, especially if you're paid for it. So that's good. Are some of you already paid for it, in which case you're good to go for the rest of the quarter? Some of you? Not yet. Okay, so bear that in mind. Anything else to talk about? No, I think I'm finished. You might well have problems, and I can understand that. But you got to get in contact with me before I see you. It's not very helpful to tell me on Tuesday when we meet, I couldn't do the last 2 sets of homework because I was stuck. So you got to make sure that you work on that. Have some of you used the help things that they've got?
I've used them, but I still get stuck occasionally, but it does help when they have some the read it and the watch it stuff.
Okay, so the read it and watch it, do that. Look at my canvas. Definitely contact me, but it's going to be hard to get me because believe it or not, I do have a life and a wife, and my in-laws are coming this weekend, and we've got all sorts of things happening, so I may not be available. So try and catch me, and I'll get back to you as soon as I notice it. But try and use the other ones first. Okay, say hi and bye-bye, and we are out of here.
Enjoy the weekend.
I will.
Mr. Robertson, is it okay
Yes.
if I ask a question on
Oh yeah,
one of the
go for it. I'm
You kinda-
free
you
right
kinda-
now. Let's use it. What you got?
It was number 26 on part A of the interest homework. Do you want me to just tell you what it was?
Okay,
Yeah.
yeah. Well, I tell you what. I want to. It'll take a little bit longer, but I've got time. So we finished early, so I've got tons of time. Let me go backwards. Eventually, I'm just going. Yeah, I'm going to go and look at your specific question because WebAssign generates different versions, and so it might be
Right.
more helpful if you see it with the numbers. Plus, I want to know what their answer is in case they do some weird thing. I'm not sure what it is. So it's
Sure.
interest part A.
Yeah, the first homework sum basically. Yeah.
Okay, I got that. Almost there.
Okay.
Oh, I forgot your name. We're looking at Gabriel, right? Was it
Yes.
Gabriel? Yeah. Okay. LMNOP. There you are, Gabriel. Click on that. And it's the first one, so I'm clicking on that. I should be able to tell in a few seconds what question is just by looking at what scores you've got.
All right. It's the last three that I'm stuck on, but if you can just go over
gotcha.
one, that's fine. Yeah.
So the last three questions. If this thing
we can
will...
just go over one. I was just wondering if we can go over 26.
26 will work. Okay, I've got 26 here. Let me leave this for a minute and show you what 26 looks like, and you can tell me if it's the same one. It's that one there. Oops, that one there. Is that the one?
Hold on. It's a blank screen right now.
Oh, you can't. Oh, that darn thing again.
Right,
let me try it again. Can you see it now?
No, I just see you. Oh, hold on. Yeah. Yes.
Okay, I just had a pause
Let's see.
before it kicked in, right? So calculate the time necessary to achieve a particular investment goal, give your answer to the nearest day, and use a 360-day year. Thank goodness they told us that. First enter the total number of full years, then give the remaining years. Okay, so the key question is just the numbers, right? So what we have is, you have $6,000, got that. And the interest rate is 5%. It's compounded daily. Okay, I got that. And you started with, so we're looking for time, right? So you need to get time. So let me get P written down as well. 3,500. Now, somewhere or other, and I hope I've still got it handy, there is a formula that you need that does that. And it better be in this list here. And here it is. So once you know the correct formula to use in each situation, it becomes a lot easier. So this is the formula that I'm going to use to get time. Okay. Oh, by the way, since it's monthly, oh, it's daily. N is 365. Okay. So the time that it takes for this money to turn into that money at 5% interest, if you're getting compounded daily, that's 365, is this fella. And it's the natural log of A, take away the natural log of P, divided by N times the natural log, and I use R over N there because it's just easier, of 1 plus R over N. Yeah, that's R, but we use a decimal form. So it's going to be the natural log of 6,000, take away the natural log of 3,500, right? What you end up with, what you start, divided by N, so 365, the natural log of 1 plus the interest rate as a decimal, divided by N, which is 365. Are you comfortable with the formula and the numbers and where they go?
Yeah.
So now we need to make sure that the calculator does it. And sometimes that can cause problems, and it causes problems because brackets are necessary. What do I mean by brackets are necessary? Put them in a different color. You need this thing inside a bracket divided by this thing in a bracket. So if you don't put the brackets in, you'll get a number, it just won't be the right number. So bracket,
right,
the natural log of 6,000. Take away the natural log of 3,500 and close two brackets. So that's basically the top row done, right? A bracket, natural log is 6,000, take away 3,500, bracket, right? Closed and opened. Okay. Divided by the bottom bracket, 365 times the natural log 1 plus 0.005 divided by 365, close two brackets. Now, the reason I need to close two brackets is one of them's this, and the other one is the guy that goes there, and there's another one up there. So you see it's two bracket thing. Now, when I hit enter, I get the wrong answer. I can tell you that right now.
What did you get? Oh, 107. Okay.
Yeah, well, I know what's wrong. My answer is 10 times too big, so I'm trying to figure out which number. Oh, I can see it. I'm too busy hitting the buttons and talking and not paying attention to what I was typing in. If you look at my decimal, I've got an extra 0, right? I can fix that. I'm going to go second entry, which allows me just to go back through my calculation. There. Now I've got the right answer. 10.78 years. So did you get 10.78 if you tried it as I did it?
Yeah, I got 10.78. Yeah.
Perfect. So now we do the last bit. 10 years is easy. This bit is where the days are coming from.
And that's
0.78.
Don't you just multiply the decimal by
say it again? Don't you
just multiply the decimal point?
By what?
By 365. And it gets daily.
Yep. And round it off to 285 because that's the nearest whole number, and it's the answer that it says it is. So it was, I'm guessing that it was, you didn't realize that was the formula that you needed.
Yeah, that was exactly it.
Right.
I knew I had that formula.
So this is 26 and I think 27 do the same kind of thing, don't they?
Yeah, it's the same thing. It's just
so it's the same formula with different numbers.
Okay.
Yeah.
The previous one, which was 25, it was
sure.
simple interest. So that's still the same formula with the time calculations, except N is different. Its number of payments per year is different.
Okay,
right?
so
Or
let's see, calculate, I'm just reading this, right? Calculate the time necessary to investment goal. Give your answer nearest day and parts of days, that's the same. But it's a simple interest and 1,000
instead of daily.
and depends. Right, now, because it's a simple interest question, this formula here only gets used for compound interest stories, right? Compounded daily, weekly,
Right.
monthly. But since this is simple interest, I'm going to do a totally different calculation on that. We want to calculate the time necessary to achieve this goal. So in this story, you started with $550 and you ended up with $1,000, and the interest rate was a simple interest rate of 6%. So in that situation, because it's a simple interest, I'm going to use a different formula, and it's not actually so much a formula that tells you the answer, but a formula that eventually gets you the answer. So I'll show you what I mean.
Okay.
That's the formula I'm going to start with. Right, that's the formula for what you would get with a simple interest story, the total amount, including the interest. So this guy is 1,000, this guy is 550, and this guy is 1 plus 0.06t. Now, this is going to be a bit messier to calculate, but it is doable. I'm going to distribute by multiplying. So that times that, that times that. So I'm going to have to use a calculator. 550 times 0.06 comes out as 33. So that's what it looks like now. Now, if you look at that really carefully, isn't that just an algebra question that you can solve the usual way? So take 550 away from both sides. Now, what do you do to find t in this story?
You divide by 33, both sides, and you cancel it out.
Agreed. And we'll use a calculator because it's going to be awkward. 450 divided by 33, and the answer I'll get is about 13.636. Now that's going to get me the 13 years. And this guy is going to get me the days. So I'm going to take 0.636 times 365, and I'll get about 232 days. And that's the answer to that question.
Okay. It's just, okay.
So
I was having
simple
difficulty
interest and compound interest, even if the stories look the same, the formulas are quite different. Would you agree in this case, it doesn't even look vaguely like this one. It's a completely different process. And the only major difference was simple interest, compound interest.
Right. Okay.